We've been talking about taking data to insights and how valuable it can be. But how is it possible? What stores data? What is data? What does it look like? Let us look through the lens of DigiBank and find the answers to these questions. Since the last video, DigiBank has grown about 10%. It's now becoming more difficult for them to manage the extra workload. As always, this video has simplified topics. It's designed to expose you to key ideas and concepts. It's based on my own personal experience and views. I would still recommend doing further research yourself. Data are images, videos, audio, text, customer details, actions, anything that can take place, anything that can be stored is considered data. It is raw and useless until it is processed and analyzed. Data can be either structured or unstructured. Structured is data stored in tables and a usable format, think something in Excel, whereas unstructured data would be images, audio and video, not easily usable or interpreted. The purpose of this video is to focus on structured data, as it can be stored easily in a database. Let's get down into the technical details. Servers are the backbone of modern computing. A server is a large computer designed specifically to handle certain tasks. One type of server is a database server. It is designed specifically to handle structured data, quickly finding information and storing it. A server will hold many databases. Think of a database as a filing cabinet. Within the database are schemas. Think of them as folders. They are a way of organizing and structuring our data. Different schemas indicate different things. You can have a schema called raw, which indicates that the associated data is unprocessed, or a schema called stable, which indicates that the data and tables are processed and can be used. Within the schema, there are tables, which are like spreadsheets, storing the data in rows and columns. A view is a file that will look at the data. It does not store the data and only exists when run. There are procedures which run code, processing and moving data between different sections within the database. They implement the coding logic. In its simplest form, you can think of servers as a filing room. They store lots of filing cabinets, which are the databases. Within the cabinets there are folders, which are referred to as schemas. And within the schemas there are tables, which store the files. Finally, procedures are the people. They're the ones who move the data around. Given this structure and process, you can pause the video and consider what the data structures could look like for DigiBank, as we are about to go through the answers. As discussed, they have a database server. It's a secure on-premise server. Within that, they have databases. The first is for tracking customer data, knowing who a customer is, their age, demographics, and other similar data. The second is for tracking relationships between different customers. There is a transactional database that stores all payments and events. And finally, there is a product database that stores the types of accounts people have. Let's walk through the process for transactional data. As it arrives, it will go into the transactional database and onto the raw schema. Procedures will pick up the data, transform it, and clean it, moving it through the different schemas until the data is refined, cleaned, and prepared. A view could possibly be used to look at the data as it is processed to confirm it is working as expected. Finally, views could be used to run reports, or alternatively, other procedures can be run to create monthly reports automatically. This process and structure allows for repeatability, traceability, and data lineage, ensuring accuracy and trust in the insights. This enables them to be valued and acted upon by the business. The database and data is also in a centralized location, allowing other members of the business to write their own separate scripts to look at the data, extracting information and insights. With the data set up this way, we'll be able to store previous data and run reports, allowing us to be both descriptive and diagnostic. And as we grow, we'll be even able to move into rudimentary predictive analysis. Thank you for watching. If you want more information, please use some of the links in the description. Feel free to leave a comment or question down below, and please subscribe if you want more content.